right. For our math workshop today, number 1 says we're rounding it to the nearest whole number. When I round that to a whole number, what is that going to become for number 1? Raise your hand if you can give me an answer. Addison? 5. So my whole number stops after the 4. If I look next door, 5 or more means raise the score, so that raises up to a 5. All right, number 2 says round to the nearest tenth. What is my answer for number 2 going to be, Caitlin? 235.6. So again, my tenth is the number after the decimal, so there's my wall. I look next door. 5 or more raise the score. That's definitely what 8 is, so 5 would raise to a 6. Let's look at the last one. Number 3 says round to the 100.
All right, teachers, everyone's back from breakfast, so y'all can post attendance. Thanks.
All right, so we're going to round to the 100. What do I get for that answer? Trent?
You said 100?
100. So round to the 100.
The 100?
Mm-hmm.
So you put an 8 at? Like, 299.
All right, but give me, so you're getting the right numbers. We just got to say that number correctly. You're getting those numbers right. Bella? 29,900. So you are correct. We're looking at that 8, so that's 1s, 10s. There's the 100, so I drew my wall. If I look next door, it is 5 or more, so that's going to raise up to a 9. What if it wasn't 5 or more? What if it was not 5 or more? What would I do in that case? Seth? You would just leave it. You wouldn't raise it at all. You would just leave it as it is. All right, so I'm going to pause our recording for a moment and pass out our notes for today. Okay, so our notes for today are going to be number 15. All right, make sure you put your name. I've given you a place to put your name. So make sure you write our name on there. This is number 15. All right, Jessica, can you pick your head up, please? Thank you. All right, the first thing we're going to talk about today is our vocabulary. All right, so a numerator. All right, we're going into some fraction talk. So fractions, we got to mention numerators and denominators. What is a numerator, Charlie? The number on the top of the fraction. That's basically the best way to remember, the number on top. All right, so we're going to label that. We're going to write out a more exact definition. It's the number above the line in a fraction that indicates how many parts of the whole amount. All right, so it's the number on top of the fraction. That's also the piece of the fraction that's telling you how many parts are we talking about. So like if a pie is cut into 6 slices, all 6 is the whole pie, correct? But if I have, 5 out of the 6, 5/6 would be my fraction. 5 is telling me how many pieces we're actually talking about out of that whole pie that was cut into 6. All right? Joseph? Oh, denominator, go ahead.
The number below the line in the fraction that indicates how many spaces of the fraction?
Yeah, so it's going to be the number below the line. It would be how many pieces it's split into, the whole amount. We're actually, so up here the numerator is important. We know that that's just the piece, that's the part. The denominator, we do want to know it's the number below the line. All right, I like how, Joseph, you're trying to get that definition worded similarly. The number below the line in a fraction, and it is used as the divisor. All right, so I don't know if we remember, but last week in our math workshop, we had a fraction that we had to change to a mixed number. And the way we did that was by dividing. And we kind of talked about how a fraction bar also can be division. The denominator is the one that's going to be the divisor. Where do you put your divisor? At the door. All right, and we're going to look at that today in just a little bit. What does the word simplify mean? So simplify, we have to do that anytime we're talking about a fraction. Addison?
It means to make a fraction that's too big into a smaller fraction.
Okay, so we're going to make a bigger fraction into a smaller fraction by dividing so that it's easier to work with, typically. So when we simplify, we're going to reduce. To simplify is to reduce a fraction to its lowest terms by canceling to the lowest number in the numerator and denominator. All right, so those are 3 new definitions that we've added. We also talked about how an old one that you might see is the word sum, meaning the result of addition. Difference, result of subtraction. Product, result of multiplication. What is the word for the result of division? Emma? Quotient. All right, so those 1, 2, 3, 4, 5, 6, 7. Those 7 definitions are what you're going to see on this test. When is your test? Friday. So, guys, you have these 3. What were the other 4 that I just mentioned? Sum, difference, product, quotient. All right, and those are all from the very first test. Those are also words that we should have learned in 4th and 5th grade. Yes, Ian? Which is even better. So those last 4, we're not writing those definitions in. We've written them out once. They should be review. Just a heads up, these 3 numbers as well as sum, difference, product, quotient. All right, we will see those again on the test that is Friday. All right, let's talk about what we're actually going to do today. Let's get into actually doing some math instead of just writing some words. All right, the first thing that we need to be able to do is we want to be able to change a Ian. Okay, I'll put it back up there. I'll let you borrow it at the end, okay? All right, the first thing we're going to do is we're going to change decimals into fractions. So we've been working with decimals. We've done a lot with them. But now I want to be able to take this decimal and I want to make it a fraction. So if I I wrote out some steps for you. All right, the first step says the number behind the decimal goes on top. So let's look at number 1. The number behind the decimal, what number do I have behind the decimal? 98. So when I make that a fraction, I'm going to put 98 on top. So there's my fraction bar. 98 is on top. We okay with that? The last place value is what goes on the bottom. So if I look at this last number, what place value is that called?
Hundreds.
That's called the hundredths. So the number that I'm going to put on bottom is literally 100. Ta-da! It's a fraction. Okay? Guys, if you have trouble with your place value, a little tip, you're always going to have like 100, 10, 1,000, a million. Okay, we probably won't go as high as a million. All right, technically it could. We just won't do that in here. All right, if you're having trouble remembering these place value, how many numbers were after the decimal? 2. How many zeros did I put in the bottom? 2. You just make sure you put that 1 in front before putting your zeros, okay? All right. Now, step 3 says to simplify. 98 and 100. Can that simplify? Mike, I see you nodding your head back there. What number can I divide those by to simplify it? 2. 98 and 100 are both even numbers. Since they're even, since they end in an 8 and a 0, we should automatically know we can divide those by 2. Okay? Now 98 divided by 2, some of us might be able to do that in our head. If you can't do it in your head, you can go over to the side, do that as some scratch work. I'm going to kind of do it in my head out loud. I know 2 goes into 9 4 times. When I have that 1 left over, that makes that an 18, and 2 goes into 18 9 times. So that's how I got 49, huh? 2 goes into 18 9 times. 9 times 2 is 18. All right. Again, guys, if we needed to, because it sounds like some of us are like, okay, whatever you say, Miss Sawyer. All right. If you need to, you can go over to the side and do 2 into 98. See how I'm working that out over here? 2 goes into 9 4 times. 4 times 2 is 8. When I subtract, you see that's the one that I was talking about that ends up in front of the 8. So now 2 goes into 18 9. So that's where I'm getting that 49. All right. Now 2 goes into 100. This one should be an easy one to split because that's just splitting it in half. What's half of 100? 50. 2 goes into 100 50 times. Okay, 49 and 50. Now those are back to back on the number line, right? So can we simplify that anymore? No, that's my answer. Okay.
Miss Sawyer,
Yes?
Nancy Addison back in the office, please.
She's on her way.
Thank you.
All right. Let's look at number 2. Now, number 2, what do you notice is different about number 2? Charlie? It has a whole number. It has a number here in front of that decimal, correct? Guys, since that number is in front of the decimal, that number is going to go in front of the fraction. All right? So, guys, since I'm writing my fractions on 2 lines, I'm going to write 15 really big in front. Because remember, my whole number and my fraction should end up being the same size. All right? If I wasn't doing a bunch of math with that fraction, I would probably just squeeze it onto one line. But since I know I'm going to be simplifying and doing other stuff, I'd rather write that whole number really big so that I have room to work with my fraction numbers. Does that make sense? Okay. All right. What number is going to go in my numerator? What's going to be my new numerator? Raise your hand, please. Numerator. Bella. 715, because that's the number that's behind it. What's going to be on the bottom? Grayson? 1,000. All right, I know that because 5 is in the thousandths place. I also know that because I put a 1. How many zeros do I need? 1, 2, 3, which is what 1,000 has. All right, so those are really big numbers. We still want to double check. Can I simplify? Can I simplify here? Raise your hand, please. Can I simplify? Ian? No? Addison, what do you think?
Yes, and do it by this 5 plus 15.
If a number ends in a 5 or a 0, it can divide by 5. This one ends in a 5, this one ends in a 0. So both of those can be divided by 5. It's really important. 5 is the one that, like, if you have big numbers, like here, 5 is definitely one we want to check. 2, obviously, we want to check. 3 and 7 after that would be the big ones, all right? So we're going to divide these by 5. Again, if I can't do it in my head, I can go over to the side. So let's see, I'm going to go over to the side, and we're doing 715 divided by 5. So 5 into 715. 5 goes into 7 once. 1 times 5 is 5, which gives me 2. Bring down the 1. 5 goes into 21. 4 times 5. 20. When I subtract, I get the 1. Bring down the 5. 4 goes into 15. 3 times. So I get 143. Since I know it goes in exactly, and we're not testing you on dividing. We can just write it out like that. All right. I got 143. Can I just write my new fraction 143 over? What has to stay with that? What has to stay with that? I'm looking for a new hand. Jose? We're making it a fraction, so we do not need a decimal anymore. All right, what has to stay with that? Kaylee? That 15, guys, that whole number, that really big number is really big because it's really important. All right, so I'm going to put my 15, and then next to that, on top, my new number is 143. All right, what are we going to get on the bottom? Micah? 200. I can do 5. 5 will go into that first number, right? 10. 5 will go into 10 how many times? 2, and then there were 2 zeros still after that. All right? Questions on how we're making these decimals into fractions? That one's pretty easy, right? Fractions into decimals are pretty easy. All right, so let's step it up. Let's look at the harder part. All right, the next thing that we're going to talk about is making a fraction a decimal. All right, that fraction bar, eventually we'll get to where we don't write our dividing with the dot dot. We'll just write it as a fraction bar. That fraction bar means we have to divide, all right? So we're going to take the numerator. The numerator is going to go inside. The denominator is going to go at the door. All right. Also, another way to remember that, denominator goes at the D for door. All right. So for this first one, example 1, I have 8 over 18, which means if I read that, I can read it as 8/18, or I can read it as 8 divided by 18. That's another way to read that fraction. All right. So we're going to put 8 in the house. 8 goes in the house. 18 is at the door. All right. Whoa, that looks weird. 18. Can 18 go into 8? No, this looks weird. But I'm making it a decimal. So what am I going to do here, Grayson? Okay, I can't add a 0 right away. You're on the right track. Before I add that 0 in, because I just can't go poof, it's 80. What can I do, Emma? We're going to put that decimal, and then we're going to raise it to the roof, bump it up. And now I can add that 0, because now it's kind of like 8.0. All right? But since I moved the decimal to the top, we're going to divide it into 80. Okay? All right, so 18. How many times will it go into 80, Addison? Do you have a question? Okay.
I'm just wondering, how, if you make a decimal into a fraction, how would it be a normal fraction? Because it usually has 100 or 1,000.
But look, see, those had 101,000, but then when we changed it, it had a 5 and a 2. So let's think about what if I gave you the number 0.8? 0.8. What would you put 0.8 over? To make it a fraction, you would put 8 over 10. And then what number can go into 8 and into 10? 2. 2 will go into those. So 0.8 would be the same as 4/5. Is 4/5 a normal fraction? 4/5 is normal fraction. All right, so why don't we look at what's happening here, Addison? And then if you have another question, I'll be happy to come back there and we'll look at it. Let's finish up our notes and we'll come and talk, okay? All right. So let's look. Are there any questions on right now on how I set this up, where I got the 80 from? Any questions about that? All right. So we have 18. How many times will 18 go into 80? Joseph? 4 times, okay? So I'm going to go ahead and I'm going to go over here to the side because before I write it on top, since I'm using a pen, I like to double check. So 18 times 4. 4 times 8 is 32. Carry my 3. 4 times 1 is 4. Plus 3 is 7. 72 looks pretty close to me, so I'm going to put my 4 up here. 4 times 18 was 72. And when I subtract 80 minus 72 is 8. All right. Is 8 smaller? Yes. Now remember, normally if this was like just regular dividing, we could put it on, make it a fraction, but we're doing a decimal here. So what am I going to do, Jessalyn? I'm going to add another 0 and bring it down. 18 into 80. Wow, that sounds familiar, doesn't it?
4.
4. We get 4 again. 4 times 18 is 72. When I subtract again, I get 8. I bring that down. It would keep making 80 forever and ever and ever and ever, right? So what does that mean about my decimal, Omar? It's a repeating decimal. How do I show that something repeats? Seth? I put a line. Now when I write my answer, so I'm going to write my answer right here next to the 18th. Was there a whole number here? No. So I can put 0 point. Do I need to write both of the 4s? No, I only need to write 1 because what am I going to put on top of it? A line. So that right there shows that it repeats. All right. Why did I put the 0 in front? There weren't any whole numbers. We just got 0.4 there. Yes, Caitlin?
What is the line actually called?
The line, it's bar notation. That's the word for it. Bar notation. All right, Kamari? Remember, for fractions, we can't have for decimals, we can't have a remainder. We have to keep adding a 0 until we get 0. Okay, that's a great question. All right, let's look at number 2. Now, number 2 is different because it does have a whole number. All right, guys, here's the cool thing. When I'm changing this fraction to a decimal, when I'm changing this fraction to a decimal, the part that I care about is the fraction. Guys, all that whole number means is that I'm going to have 5 point something else. So just like that whole number is in front of the fraction, that whole number is going to go in front of the decimal. All right? So when I'm actually dividing, I only need the 16 and the 20. Okay? So I'm going to put the 20 at the door because it's in the denominator. And then my 16 goes in the house. All right, now again, y'all are going to see we ran into the problem. Can 20 go into 16? No. So what do I do, Omar? Add a decimal and then a 0. All right, now that decimal, is it going to stay in the house with that 16? No. What's going to happen to it? Where's it going to end up? Raise it up to that roof, okay? So now I'm dividing 20 into 160. How many times is that going to happen? Ian? 8 times. So since I'm putting 20 into 160, I'm going to make sure I write the 8 on top of the 0. 8 times 0 is 8, and then 8 times 2 is 16. So I just got 0.8. So what is my answer? What is my final answer going to be here? Evan? 5.8. That 0.8, is that my final answer?
Yes, no.
No, I've got to put it with the 5 that was in front of the fraction. Okay. Do we have any questions about this so far? All right. Do you see how the 5 was in front of the fraction? Okay. Can you see on your paper better? Okay, on number 2, there's a 5 in front of the fraction, correct? which means I've got to put a 5 in front of my decimal, which is why it's 5.8, not just 0.8, which is what we got wrong. Okay? Yeah. Then you're good. All right, so on number 3, again, guys, I like to do this just so I don't forget. I'm going to go ahead and put my 7 with a decimal, so then I can just write my answer in next to that. All right, how am I going to set this up? So I've set up the first 2. How am I going to set this one up? Seth? Put the 4 inside, and then 45 outside at the door. All right, what do I need to do here, Jesslyn?
Well, I was going to say add 0, but then you still
That's true, but that is an important step. So we still have to do that step. But what do I do before I add the 0? That 0 is important, but what else is extra important? Gabe, help me out. The decimal. All right, so I'm going to do the decimal and a 0. Make sure we raise it to the roof. All right, so guys, that 0 was important. Can 45 go into 40? No. So guys, we have to put a 0 up on top. All right, because it went in 0 times. Now what can I do? Come on. Yeah, we could do 40 minus 0. We could continue working that out. So we could do 0 times 45 is 0. When I subtract, I get 40. Now what do I need to do? Trent? Add another 0. So now I'm putting 45 into 400. How many times do we think that will happen, Joseph? 8. So I'm going to go over here to the side again, just because these numbers are a little bit big. So 5 times 8 is 40. Carry my 4. 8 times 4 is 32 plus 4. So I get 360, which seems like it's closer to 400. What if I thought it could go in one more time? What could I do? What could I do if I thought it could, Ian?
You have to do the 9 times.
I could multiply 45 times 9. All right, now this, I don't think this is going to work. Yeah.
could you just add
Okay, all right, so I want to talk about what Gabe is mentioning, all right? And I see a lot of y'all doing on this paper where you multiply and then you just add 40 to see if it will work. There's nothing wrong with that. But the problem is, guys, what if I messed up on this multiplication? Then every other answer I get is going to be wrong. I've seen people do that. They'll mess up multiplying that first number and then they start adding, and then they're never going to get the right answer because that mistake is going to keep going through. All right? Personally, I like to go ahead and do that extra multiplication problem just because then if I made a mistake on the first one, is it going to keep going? No. All right, so 9 times 5 is 45. Carry my 4. 36 plus 4 gives me 405, which y'all already said it was going to go over. So let's use 8. 8 times 45 was 360. When I subtract 400 minus 360, what are we going to get there? Jose? 40. All right, you could borrow here. We could do 0 minus 0 is 0. I can't do the 0 minus 6, so we borrow, making that 3. So 10 minus 6 is 4. All right, I got 40. Is 40 smaller? Yeah, so what are we going to do? Add a 0, bring it down. I get 400. That sounds familiar. Let's just do it one more time to double check. 8 times 45? 360. 400 minus 360 is 40. That math problem repeated twice. So what do I know is happening to that 8? It's repeating. Someone tell me, how am I going to write my final answer? Final answer here. Maddie, what do you think? With a bar? That's correct, but remember, what's in front of that? You said the decimal. Rachel? That 7 that we've already written in, we need that 7.08, and we do have that bar on the 8 to show it's repeating. All right, guys, are there any questions on how we did either one of those? All right, your homework tonight, we have 6 problems. that we're going to practice making them fractions. And then we have 6 problems where we're going to practice making them decimals. Alright? So, your work, there's plenty of space for you to do your work.